Hi everyone, in this video I would like to talk about our work, namely an effective end-to-end modeling approach for mispronunciation detection. I'm Luo Tianhong, a student from National Taiwan Normal University. Today I will divide this talk into three parts. First, I'm going to start with a brief introduction about our work, including what does CAPT mean, motivation, and our contribution. Then, I will talk about the model architecture proposed in this paper, hybrid CTC-Attention model with test prompt and two novel extensions in conjunction with CAPT model. And finally, there are experiments and conclusion. Okay, what does CAPT mean? CAPT is short for Computer Assisted Pronunciation Training, which manages to pinpoint error pronunciation in the utterance of a L2 learner in response to the test prompt. This figure shows the scenario for CAPT system. A user reads the test prompt and say, "What is for your lunch?" with microphone of computer or mobile. Then the CAPT system will give the feedback of user's pronunciation to user. There are two common feedbacks, detection and diagnosis. The former aims to pinpoint errors pronunciation, and the later aims to diagnose how the wrong pronunciation sounds like. The main discussion of this paper just focuses on mispronunciation detection task. Here are some motivation about our paper. First, the conceptual simplicity and the practice effective of an end-to-end manner have recently propounded considerable resource efforts. Hence, conventional ASR architecture can be replaced with an integrated end-to-end modeling framework. Second, the end-to-end based modeling, CTC model, has also been introduced to MD with a promising resource. In comparison to the GOP-based method that builds on the hybrid DNHA acoustic model. This figure shows flowchart of end-to-end based CAPT system. In training phase, the ASR model was trained on utterance produced by L1 and L2 corpus. Note that each utterance of L2 may contain mispronunciation. In testing phase, the utterance will be judged whether correct or incorrect according to the resource of this decision function. And I will focus on ASR modeling technique and the decision function in this paper. We will discuss this matter in a little more detail as we go on. There are three main contributions to this paper. We first present a novel use of hybrid CTC-Attention approach to the MD task, taking advantage of the strengths of both CTC and the attention-based model, meanwhile getting around the need for phone level forced alignment. Second, we perform input augmentation with the test prompt information to make the resulting end-to-end model more tailored for the MD task. On the other hand, we adopt two MD decision methods so as to better cooperate with the proposed framework. First, decision-making based on the recognition confidence measure. Or second, simply based on the speech recognition results. Okay, let's move on to the model architecture. In this session, I will then touch on the hybrid CTC-Attention model and show our proposed architecture, including test prompt augmentation and the two extensions to CAPT model. Okay, hybrid CTC-Attention model combining the strengths of both CTC and the attention-based model was first proposed in 2017. This model can be utilized CTC to assist the attention-based model to compensate for the misaligned problem and improve the speed of the decoding process. The objective function shown in this slide where lambda is introduced to specify the relative importance of CTC and attention. Okay, I will now move on to the end-to-end based MD system. that we propose. Our architecture proposed in this session is inspired by first paper, and the similar work is second paper, SED-MDD, proposed in ICASE for 2020. Different from the first paper use arbitrary synthetic text. We use the text prompt of the text alternance for text-based augmentation. With the novel use of text prompt, we aim to make the resulting hybrid CTC-Attention model more tailored for the MD task. More specifically, if mispronunciation training alternatives are available in the training phase, it is anticipated an augmented encoding of the reference text prompt can serve as a clue that make the training MD model more concentrated on predicting the mispronunciation form. Okay, let's discuss text prompt augmentation more detail. The MD system is augmented with the phone label symbol sequence Z. They correspond to the reference text prompt of training alternance, where ZI denotes the symbolic representation of the arbitrary phone I. To display the institutions of the phone label symbol sequence, phone string and the repeated phone string are highlighted in the table 1. Phone string is a phone label symbol sequence of a text prompt as the input. Now that in the training and the test phase, it is expected that the output sequence of a neural network should be the phone label sequence that a speaker has actually uttered. Repeated phone sequence is the phone label sequence of the text prompt have probably repetition of each constituent phone, which reflect the relative duration of phone in the training data set. The second part, we are going to talk about two extensions to our CAPT model. First, in order to compare with the strong baseline GOP-based method, we design a confidence measure for use of our MD system. Similar to conventional GOP-based method, we natively constrain the end-to-end model at each time step. Can only output a phone label symbol that evolves in the text prompt. The posterior probability of CL given X is then taken as the input to a decision function D. When the indicator equals to 0, it indicates the CI has been mispronunciation. Thresholding parameter R is determined based on the ROC curve. The second one is speech recognition results. We can simply recast CAPT as an ASR problem. In other words, the output phone label symbol of the hybrid CTC-Attention model at each time step is first aligned with the phone label symbol at some position of the text prompt with the shortest edit distance criteria. If any pair of such alignment contains phone label that are not indicator, it signifies the phone label mispronunciation error. Okay, the next one is the experiments and the conclusion. Our MD system with the hybrid CTC-Attention model was built on the ESP network key, while the GOP-based MD system with the DNHA model was built on KLD tool key. The dataset employed in this study is Mandarin annotated spoken corpus, compiled by the Center of Learning Technology for Chinese, National Taiwan Normal University, between 2012 and 2014. Table 2 brief highlight the statistic of the speech corpus. The default evaluation metric employed in this paper is the F1 score, which is the harmonic mean of precision and recall. This slide shows a definition of evaluation metric. It is worth to be mentioned that we only focus on the mispronunciation detection. At the outset, we evaluated the performance of two variants of our baseline MD system built on top of a hybrid CTC-Attention model denoted by the CTC-Attention. In comparison to the celebrated GOP-based method, as well as its extension that leverages the MISMA F1 criteria denoted by GOP-NFC, as can be seen from the Table 3. CTC-Attention with confidence measure performs on par with the GOP-based method, but is infer the GOP plus MFC that fully employs the MFC to train its component DNHN model. However, CTC-Attention with speech recognition outperformed both GOP and GOP plus MFC by a big margin. This is also revealed the end-to-end based modeling, such as CTC-Attention, holds excellent promise for the MD task. In addition, CTC-Attention with speech recognition shows its superiority over the CTC with speech recognition. In terms of the precision performance, in the last set of experiments, we assess the effectiveness of augmenting the associated text prompt of a given utterance for use in our MD system. Two variants of the text prompt augmentation approach are evaluated here. The phone string methods PS and the repeat phone string method RPS. There are two noteworthy responses to this result. First, the additional use of text prompt augmentation can offer a relative F1 score improvement of roughly 1.5%. Second, the two varieties of text prompt augmentation are quite competitive with each other. We believe that further investigation of more elaborate text prompt augmentation for the end-to-end based MD task would still be desirable. Okay, in this paper, we put forward a novel modeling paradigm for the mispronunciation detection task, for which display the model, structure, and the variant of the text prompt augmentation have been investigated. A series of MD Mandarin mispronunciation experiments demonstrated that our approach not only simplify the process pipeline of its existing hybrid DNHN system, but also brings about a systematic and substantial performance improvement. In future work, we plan to explore more elaborate ASR system and extend to the text prompt augmentation approach. In addition, we would like to further investigate other effective optimization criteria for training the component model of our end-to-end based MD system. Okay, this is the end of my talk. If you have any question about this paper, please feel free to contact me by this email. Thank you for listening.